be doing section 4.5, which is graphing with slope-intercept form. This is one of the most important sections in this chapter, and also maybe even one of the most important lessons in all of Algebra 1. The good news is we've probably seen it before, right? All right, because most of my students tend to be already knowing y equals mx plus b, which is a good thing. And another way we see it written sometimes is f of x equals mx plus b. So if you see it like that, f of x equals mx plus b, then that's just in function notation. So it's linear. This one we call a linear equation. If it's in function notation, we call it a linear function. Okay? But f of x just means y. It means the output. So let's just talk about what m and b represent. Now, we already know from Friday that m represents the what? The slope of the line. What is a slope? It's a measure of what? How steep the line is. Very good. All right. Does anybody know what b refers to? What is b in y equals mx plus b? Does anybody know? It's the y-intercept. Now, we also talked about intercepts on Friday. What is a y-intercept? Where your line crosses the y-axis. That is right. Okay, so the first thing, we're not going to have to graph it all. What they're wanting us to do is just tell what the slope of the line is and what the y-intercept of the line is. Okay? So if it's in y equals mx plus b form, if it's in slope-intercept form, that should be really, really easy for us to do. Right? So problem A right there is it in slope-intercept form. Yeah, I got y right here and x right here, a number in front of x and a number at the end. So yeah, it's in slope-intercept form. So we should be able to pick out our m and b. So what is in the m spot on problem A here? 3. So the slope is 3. And what's the y-intercept? 4. So if the y-intercept is at 4, what's that ordered pair that the line's going through? What's the ordered pair of the coordinates? 0, 4. Okay, so it might want the coordinates instead of just b equals 4. Okay, so all you have to do is look in their spots, pick out your m and b. Okay. Now what about problem B right there? Negative 2x plus 3y equals negative 15. What's up with that? It's not in slope-intercept form, right? You know you're in slope-intercept form if it has y equals something with x plus or minus a number, okay? And this does not say y by itself. So we're going to do that stuff to move around and solve for a specific variable that we started practicing in chapter 3. So how do we get y by itself? Add 2x. And since we're definitely doing slope-intercept form, when I put it on the other side, I need to put it in front of the minus 15. So I'm going to say positive 2x minus 15. And now what do I need to do to get y by itself? Divide everything by 3. All the terms by 3. 3 divided by 3 cancels out because it makes 1. So that's just y by itself. And then you simplify your fractions. So what is 2 over 3x? That just stays 2/3 x, right? And what is negative 15 divided by 3? So minus 5. So any questions about how we got y equals 2/3 x minus 5 for slope-intercept form? All right, we did all that so we could pick out the m and the b. So what is the slope of that line? 2/3. Positive or negative slope then? Which means the graph's going to be doing what? Going up from left to right. And what's my b? Negative 5. So what's the ordered pair for my y-intercept? 0, negative 5. So if it's in slope-intercept form, you pick out the m and b. If it's not in slope-intercept form, you put it in slope-intercept form and pick out m and b. Okay? So any questions? So that was just a little bit of practice of dealing with the equation, getting them in slope-intercept form, picking out the key things. Now we're actually going to use slope-intercept form to help us graph a line. Okay, so we need graph paper for this. Go ahead and write down example C is y equals negative 2/3 x plus 1, please. And then go ahead and draw you an x and y axis. This one doesn't have to be very big. Thank goodness. All right, when you get your axis drawn, I want y'all to look up at me so I know not to rush in front of anybody. Okay, so when you're graphing a line, now I know y'all have done this before, but this is review, but it's important, okay? When you're graphing a line and it's in slope-intercept form, you're going to start with your B. Always start with your y-intercept, okay? That's your first point on your graph. Now, what is our y-intercept for this equation? B is 1. So our graph is going to start at the point 0, 1. Now, where is 0, 1? It's on the what? The y-axis. You know, y'all, we don't put our points on the x-axis. We start on the y-axis. That's what y-intercept means. So your first point is right there at 1 on the y-axis. When you're graphing with slope-intercept form, you always put the first point on the y-axis. That's what y-intercept means. Okay? Then your slope tells you where to go from there. So your slope is, your B is your starting point. Your slope is your directions. Okay? So, what is our slope? Negative 2/3. Now, when I have a negative slope, I like to put the negative with the top number. And remember, it's rise over run. Okay? So you're going to start at that 1. That's your starting place, is your y-intercept. And where does my rise tell me to go? Negative 2 means down 2. And then we run which direction? To the right, how many? 1, 2, 3. Always run right so your graph won't be wrong. Always run right so you won't be wrong. And y'all, if you've got 2 points and you did your slope correctly, let's stick a line on there through your 2 points. And make sure you put arrows on it. Technically, if you don't put arrows on your line, it's incorrect. Lines go forever. Okay? So it's the same steps every time. Graph your y-intercept, and then do rise over run to get your next point. Draw a line, put arrows on it, and you're done. Okay? Slope-intercept form is the easiest way to graph, in my opinion. But we have to learn all the different methods because not everything's as easy as slope-intercept form, especially when we get to like exponential and quadratic functions. All right, the next one, is it in slope-intercept form? Yes, so that equation's ready to graph as well. Pay attention. My y-intercept is what? Negative 5. So I need to make sure my graph is able to go down to negative 5. Okay? So I'm going to draw it like that, kind of bigger on the bottom 2 quadrants. All right, where does my first point go? Yeah, on the y-axis. First point's always on the y-axis. So it's negative 5. So 0, negative 5 is my first ordered pair. 1, 2, 3, 4, 5. So there it is. Are we okay with that? What's my slope? 4/3. So I start at 0, negative 5, and where do I rise? Up 4, and where do I run? What does over mean? To the right, 3. So now you got 2 points. Draw your line. arrows on them, please. Any questions so far? Is everybody good? Everybody good? Okay. Well, those are easy because they were already in slope-intercept form for us. So now we're going to start seeing some where we have to do a little bit of work to them first. So write down that first equation for problem E, 2x plus y equals 3. Now what do you think is going to have to happen first? Right, we got to make it look like y equals mx plus b, correct? Got to make it look like slope-intercept form. So, being told to subtract 2x on both sides, and I agree. Then I have y equals what? Yeah, watch your sign. So negative, it was with the 2x, and 3 is positive, so it's plus 3. So you keep the sign that's in front of them, okay? So now are we in slope-intercept form? Yes, we are. So now we can get ready to graph it. Oh, that's cricket. All right, what's my B? So my first point is at what point? 0, 3 on the y-axis, which is right there. First point is always on the y-axis when you're doing slope-intercept form. What's your slope? Now, okay, if it's a whole number, I need to run somewhere. So what's my run number if I have a whole number? Right, negative 2 is the same thing as negative 2 over 1. So you got to run someplace. So if it's a whole number, put it over 1, please. All right, so now we're going to graph our second point. So I started my y-intercept, which was at 3. And where does my slope tell me to go? Down 2 and run to the right how many times? Now, y'all, when you're drawing your graph, don't do this. Okay? Make your graph of your line proportional to the size of your axis, okay? So extend that line, make it a longer line, okay? It's easier for me to check them and make sure they're correct if they're longer. Yeah, you can keep doing the slope. I can keep going down 2 over 1 multiple times, okay? I don't make y'all do that in this section. I do when we get to chapter 7 and we're doing systems of equations and I need to see where they intersect. But for right now, we're just practicing 2 points is fine for me. Okay? But if you want to keep doing the slope multiple times, you can. Actually, that's more accurate. But I get lazy. But yeah, you can do. Shoot, Lord have mercy. But yeah, you can do your slope as many times as you want. I just require that you just do it once, okay? So that you have 2 points. Because technically, that's the addition of a line is it contains at least 2 points. All right, look at F. What are we going to have to do first with problem F? Yeah, we got to make it look like y equals mx plus b. So subtracting 1x.
Miss Isbell.
Yes?
Hold Jarnigan needs to come to the office for a minute, please.
All right, thank you. So I subtract 1x on both sides. So that is 2y equals, now you can leave it negative x, or you can make it negative 1x. I'm probably going to make it negative 1x because I'm about to have to divide both sides by 2. Okay, so it just makes more sense if you have the 1 there. I'm not going to make you, but you just got to understand that now I have to divide everything by 2. And I got to make sure I get it correct. That's supposed to be negative 1/2. X plus, what's 4 over 2? 2. Okay. So any questions about how we got that one in slope-intercept form? Mm-hmm. So let's draw our graph. Oh, straight lines, Mrs. Wolf. Today is not my day for straight lines, apparently. What is my y-intercept? 2. So I go to 0, 2 on the y-axis. What's my slope? Negative 1/2. So I start at 0, 2, and where do I rise? Up or down? Up or down? Down. It's negative 1/2. So I go down 1, and where do I run? Right 2. And again, you can do that multiple times if you want to make the line straighter. You can actually go backwards. Something like that. We're getting it. It's clicking. We've seen it before. We're awakening those parts of our brains that we shut off for 6 months. Right. You guys try this one. What are we going to have to do to this one first? Slope-intercept form. Yeah. Slope-intercept form. All right, a lot of you are done. So if you're done, go ahead and check it with somebody, please. Okay, so y'all help me out, please. What did you have to do first on this problem? Yeah, because you have to do what to your equation? Put it in. That's right. Make it look like slope-intercept form, okay? We can't graph using slope and intercept if we can't pick those out. So we got to get it slope-intercept form. So we said what first? Everybody do that first? Good. Then that left you with what equation? Well, 2y equals positive 3x minus 6. Is everybody good so far? Now what do? Divide everything by 2 and simplify, correct? So that makes just y equals what? Is it okay to have your slope an improper fraction? Absolutely. We actually don't want mixed numbers for slopes because that's kind of, you need a rise and a run and that's it, okay? So if you have a mixed number for a slope, we would need to change it to an improper fraction anyway. All right, so what is my y-intercept? -3. So we start at 0, -3, which is on the what? Y'all, your first point should be on the y-axis. Y'all, I've graded these papers on this type of problems for 12 years, and I have people start on the x-axis all the time. Yes, sir. You don't have to, but let me just say you have a quiz tomorrow and say you misgraphed it just by, like you miscounted or something. I would rather see that so I can give you some kind of partial credit. You know what I mean? So say you know it's at -3, but you accidentally counted too much and went to -4. I can at least give you something partial if I knew that you knew it was supposed to be -3. Does that make sense? So technically no, but it helps. So 0, -3 is right there, correct? What's my slope? 3/2. So I should already know my line should be going up from left to right, right? If that slope is positive, my graph better be going up. Okay. Now what's my rise from 0, -3? 3. So I rise up to 3, and I'm right there at the origin. Then I run to the right. How many? 2. And that one just happens to be on the x-axis. It's not always going to happen. It just does. So then you pop a line right there, arrows on it, and raise your hand if yours looks something like mine. Are there any questions? Y'all did good, okay? So we still got to know how to get y by itself, because if it's not, it's going to be hard to graph it with slope-intercept form. All right, the last thing I want to show you is a few little special types of problems like this, special cases. So the first one says y equals 2x. Now, why do you think this one is special? It doesn't have a b, does it? Okay? So actually it does have a b, it's just not shown in the equation. What do you think b is?
0.
Yes, if you don't have a b, then your b is 0, because 2x is the same thing as 2x plus 0, is it not? Right, so if you want to stick that plus 0 in, that is fine. So that means your y-intercept is where? At the origin. If your b is 0, that means you're crossing the y-axis at the origin. So you're going to start at the origin. Only if they don't give you a b. If they give you a b, you got to use whatever b that is. If they don't give you a b, and they give you a number in x, then your b is at 0. Now, what is our slope? Remember, whole numbers go over 1 so you can run somewhere. Okay? So where do I go? Up or down? Up 2, and where do I run? To the right 1. Stick a line on it. So if they don't give you a b, use 0 for your b. Any questions about that one? All right, the next one says x equals -3. And I think the other day I told you to memorize some things, right? I told you about 4 things to memorize, I think, for this chapter. Well, actually, about 5. Maybe. There's a lot to rememberize from this chapter. So I told you to memorize what it means for x to equal a number for a linear equation. What does x equals a number mean for a linear equation? Do what? That's exactly right. Your line is vertical. If you don't have that memorized, you need to be memorizing that. X equals a number is a vertical line. Y equals a number is a horizontal line. Now, if it's vertical, what axis is it going to cross? Which one? If I could draw a straight x-axis, I might could graph it something. Sugar, that's close enough. I told you to remember it. X equals a number is a vertical line that crosses the x-axis. Okay? Whatever variable it says, that's what axis you're crossing. And if it's vertical, it won't necessarily cross a vertical axis, right? It's got to cross something going the other way, right? So it's going to cross the x-axis. Now, where's it going to cross the x-axis at? At -3. So all you do to graph this line is go to -3 on the x-axis. It tells you what axis. Put a point. And then you're supposed to memorize that that is vertical, and you just drop a vertical line, put arrows on it, and you're done. Easy as pie. I don't know. I don't cook many pies. I don't know if they're easy or not. I don't think I've ever baked a pie. I cook all the time. I'd rather have cake, I guess. Yeah, eating pie. If I see pie, I'm going to eat it. Unless it's math pie, I don't eat those pies. All right, so y'all memorize. X equals a number is a vertical line. So y equals just a number is a what? Horizontal line that crosses what axis? The y-axis at that number, okay? Like problem I right here. It says y equals number 1. So, what kind of line is this going to be, y'all? Horizontal. Memorize, memorize, memorize. So, stop it. If here's my x and y axis, I'm going to graph my line in red. I cross which axis? The y-axis where at? At 1. And just drop a, oh, I cannot draw lines. I guess I should get my ruler out. Put arrows on it. Okay? So it tells you which axis you're crossing and where you're crossing it at. Got a +1 on the y-axis and it's horizontal. Okay? So memorize. Y'all, I've made your test already for chapter 4. We're probably going to have it borrowing snow days. I hope it snows. Y'all want some snow?
Yes, Thursday. Yes.
Borrowing snow days. It's going to happen early next week. Okay? So like Monday or Tuesday-ish of next. It won't be Monday. Probably maybe Tuesday. We'll see. All right. So it just depends on if we get out or not. I'm hoping we do. So y'all okay with that horizontal and vertical? You cross that axis at that number. Okay. So those are your special cases. Last thing I want to talk about is some parallel lines. And I thought this should really be in the slope section, but they didn't. They put it in this section instead. So I want you to write down this definition of parallel lines. It's really not the definition, but it's a important thing about them. And then I want you to get out your book after you write that down. It says page 246, so if y'all would turn there. We're going to talk about parallel lines for a moment. So tell me something else you know about parallel lines. They never do what? They never cross each other, okay? Never, ever, ever do they cross each other. Now, we know that lines go forever across a plane, okay? So, even if you're looking at a graph on a piece of paper, and they don't cross on that piece of paper, guess what? They could still cross eventually, okay? So, to see if a line will ever cross or not, we have to look at the slope. If the slopes are the same, they will never cross. Okay? So, you cannot, like I'm saying, you cannot just look at a picture or a graph and tell, because graphs, pieces of paper are finite. They have an end to them, right? Lines do not have end. Okay? They can run off the page and run for forever. All right? So, look at page 246, that example 5. You see a blue line, red line, and a green line. Right? Y'all see those 3 lines? Look at them. Look at them. It looks like red and blue are not crossing, right? Don't look like any of them are crossing, right? It looks like red and green might cross at the bottom part. Y'all see that? But again, you cannot just look at a picture and tell, because it's not showing them crossing anyway. So what you have to do is test their slopes. So I'm going to do it for all 3 lines. And this will help us review. So y'all help me for the blue line. Remember, the formula for slope is m equals y2 minus y1 over x2 minus x1. So what are the 2 ordered pairs they have on the blue line? -1, -1, and 2, 0. So if I plug those into my formula, what's y2? Minus -1 over what's x2? Minus -1. So that makes 0 plus 1, which is 1. 2 minus -1 is 2 plus 1, which is 3. So the slope of the blue line is 1/3. Y'all agree? Now I'm going to do that for the other lines as well. Okay? So that's the only way you can make sure lines are parallel, is by checking their slopes. So the next line down is the red line. I'll do it in red. What's the ordered pairs of the lines on the points on the red line that they marked? And 5, -1. So I'm going to use the same formula. What's my y2? Minus what is y1? Mark the signs, use parentheses. Over what's x2? 5 minus 0. So that's -1 plus 3, which is what? +2 over 5 minus 0 is, and that will not simplify anymore. So are the red line and the blue line parallel? No, they are not parallel. They look like it on my picture, but they are not parallel. Okay? So now let's check green line. What's the 2 ordered pairs on the green line? And 4, -3. Pop them into the same formula. What is y2? Minus -5. Use parentheses. Over minus. Okay. So on top, that changes to -3 plus 5, which is 2. Over 4 plus 2, which is, does that reduce? To 1/3. So what can I say based on slope? What never crosses? All right, so I can say blue and green are parallel based on slopes. Okay? So that would be how you would check to see if 2 lines are parallel to each other. You have to check their slopes. All right? Now, you could have done rise over run with those graphs, right? Since I gave you the graphs. Could you have done that? Start at the point on the left, do rise over run to get to the point on the right, and then simplify. So you could have done that as well. All right, we're going to stop right here. This will be the end of section 4.5. Have a good day.